Welcome back, dear students. As you know that we are dealing acid, bases and salts. We completed acid, we completed bases also. We are dealing most important part, that is third part of our chapter second, salts. In that we see what is salts. Salt is an ionic compounds which contains a positive ion other than hydrogen and a negative ion other than hydroxyl ion. When this we seen that preparation of salts, when acids react with base, at that time it forms salt plus water. How we can classify these salts? We seen about it also. So once we will look it, when strong acid, strong base reacts, it gives neutral salts. When weak acid, weak base, it gives neutral salt. When strong acid reacts with weak base, it gives acidic nature of salt. After that, strong base, if we are using strong base and weak acid, at that time it form basic in nature salts. Okay, so salts are, from that we can conclude that, from this table we can conclude that salts can be acidic in nature, basic in nature or neutral in nature. After that we see some information about the sodium chloride which is used in our daily life. Okay, that is NaCl. It is called common salt, okay, or table salt. So this we see. After that we see some common products which is obtained from the sodium chloride. In that we see first one, that is sodium hydroxide. Sodium hydroxide is known as caustic soda and it having chemical formula, that is NaOH. NaOH is manufactured by passing electricity through an aqueous solution of NaCl. Okay, if we are passing electricity through the aqueous solution of NaCl, at that time what happens? That process is called brine, which decomposes to form sodium hydroxide. When it decomposes, it forms sodium hydroxide. This process is called Chlor-Alkyl process. Why it is called Chlor-Alkyl process? The reason behind it is, in this reaction, products form chlorine. Okay, chlorine we are using here chlor and alkali for NaOH. Okay, so in this way we prepare NaOH. NaCl reacts with the H2O by passing electricity, it decomposes into the NaOH. It forms Cl2 and H2O in the aqueous. Okay, called at the anode. Where these are gathered, we know that at anode cathode we also see this also. Also we see some properties of the NaOH and uses of NaOH. Okay, now in the today's part, okay, we are going to see that baking soda, bleaching powder, washing soda. After that we are showing we are going to deal about most important, that is plaster of Paris. Okay, this all salts we will see with the help of AV and with the help of slides. First we will see the slides on it. Along with I will give description about it, and after that we will see small AV regarding on all salts. Okay, so please pay your attention and watch it. We will start to learn about baking soda. What is baking soda? Baking soda having formula NaHCO3. Its chemical name is sodium hydrogen carbonate. What I am saying? Sodium hydrogen carbonate. It is a chemical name of baking soda, or it is also called as sodium bicarbonate. Now we will see preparation of sodium hydrogen carbonate or bicarbonate or baking soda. NaHCO3, it means sodium bicarbonate, okay, or sodium hydrogen carbonate or baking soda is prepared in the laboratory which is prepared in the laboratory from sodium chloride. From where? Sodium chloride. Just we have to pass carbon dioxide gas through a cold solution of sodium chloride saturated with ammonia. Saturated with ammonia. Okay, so the reaction will be NaCl plus NaH2O plus CO2 plus NH3. What we are going to treat? We are just reacting sodium chloride. It means we are just making aqueous solution of sodium chloride. We are passing CO2 gas in presence of NH3 saturated ammonia. Okay, then what we will get? We will get ammonium chloride plus sodium hydrogen carbonate. It means our baking soda is getting produced. Okay, so this is preparation of baking soda. Now we will learn about some properties of baking soda. It is a white crystalline solid sparingly soluble in water at room temperature. Second property is when we are dissolving this sodium bicarbonate into the water, the solution becomes alkali in nature. Alkali in nature means basic in nature. Okay. Third property, pH of this solution of baking soda is greater than 7. Therefore, it is used to neutralize an acid. Its pH is more than 7. So, we are going to be use this baking soda for the neutralization of acid. Okay. Next property is it is a mild and non-corrosive base. It is mild. Okay. It is not harmful for us. So, it is non-corrosive base. Action of heat. Next property is action of heat. When we are heating sodium bicarbonate, okay, or baking soda or sodium hydrogen carbonate, at that time sodium carbonate is going to be formed plus CO2 gas and H2O we will get. Okay, it means it is forming CO2 gas. These are the properties of baking soda. Now we will try to understand about some uses of baking soda. First uses of baking soda is used in making baking powder. It is used for making baking powder. It is used to prepare baking powder. Baking powder contains sodium hydrogen carbonate. Baking powder contains sodium hydrogen carbonate and mild edible acid. Which acid? Edible, which we can eat. Okay, like tartaric acid or citric acid. Like tartaric acid or citric acid. Baking powder is different. Baking soda is different. Okay, baking powder contains sodium bicarbonate plus edible acid. It may be tartaric acid or it may be citric acid. When baking powder is heated or mixed in water, it gives following reaction. Following reaction means whenever we are reacting baking powder, when we are heating baking powder or mixed in a water, at that time what happens? From water we are getting H plus ions, okay, to this sodium hydrogen carbonate. It means from any acid, okay. So it forms CO2 gas mainly plus water and sodium salt of acid. Sodium salt of acid we are getting. Okay. Next use of the baking soda is used in medicines. Baking soda is used in medicine as an antacid. Now only I told that while mentioning the properties of acid. It is a mild base and non-corrosive. That's why we are using this base for the neutralization to the acid. That's why we are using this baking soda as a medicine for antacid. Okay. Next use is it is used in manufacturing of soda water. It is used in the manufacturing of soda water. Next use, sodium hydrogen carbonate is used in the fire extinguishers. Why we are using sodium hydrogen carbonate in the fire extinguishers? Because it produces CO2 gas, and we know that very well. With the help of activity also we see that CO2 gas does not help to the fire. So it is used in the fire extinguishers. I hope that you understood about baking soda. Okay. Now we will try to understand about powder. Bleaching powder having formula CaOCl2. CaOCl2. Its chemical name is calcium oxychloride. Its chemical name is calcium oxychloride. Okay. Also it is called chloride of lime. Also it is called chloride of lime. Okay. So now we will see the preparation of bleaching powder. Bleaching powder is prepared by chlorine gas. From where we are going to prepare? By chlorine gas over dye-scaled slaked lime. Over dye-slaked lime. It means that calcium hydroxide, okay, which should be dry. So we are just reacting this chlorine on calcium hydroxide. It is called slaked lime. Okay, see the reaction. Calcium hydroxide or slaked lime reacting with chlorine, at that time it will form bleaching powder. It means calcium oxychloride plus water. I hope that you understood this preparation of bleaching powder, which is very easy. Keep in your mind. Okay, you should remember this, the all preparation of salts, properties and uses. Okay, so now we will see about properties of bleaching powder. Bleaching powder is yellowish white powder. It is what? Yellowish white powder. It gives strong smell of chlorine. It gives strong smell of chlorine. Don't forget it. It gives strong smell of chlorine. It is soluble in cold water. It is soluble in cold water, giving a milky solution due to free lime present in it. Why it is giving milky solution? Because of free lime present in it, that is calcium hydroxide, okay, present in it. That's why it is giving calcium hydroxide is there now, so it is forming milky solution. Okay, so these are the properties of bleaching powder. Now we will see the reaction on calcium oxychloride, means bleaching powder, with CO2. What happens whenever this calcium oxychlorides reacts with CO2? It forms calcium carbonate and Cl2 gas. It gives Cl2 gas. It means chlorine gas. When this bleaching powder reacts with acids, at that time it forms calcium chlorides, water and Cl2 gas. Okay, chlorine gas. So these are the properties of the bleaching powder. Now we will try to understand about the uses of bleaching powder. Bleaching powder is used for bleaching cottons. It is used for the bleaching cottons, linen in textile industry. Okay, in which industry? It is used for bleaching of cotton and linen in the textile industry. Next use is, it is used for disinfecting or drinking water to make water free from germs. It is used as a disinfecting. Okay, for we are just making water suitable for the drink. So it makes water free from germs. Okay, so this is the most important use of bleaching powder. It is used in the manufacturing of chloroform also. This is also very important use of bleaching powder. We know that uses of chloroform. What happens while we are smelling chloroform? It gives anesthesia. Okay, anesthetic. So these are the uses of bleaching powder. Again, this bleaching powder is used an oxidizing agent in the laboratories and industries. It is used as an oxidizing agent. Oxidizing agent means it gives oxygen. Okay, in the laboratory and industry. These are the uses of bleaching powder. I hope that you understood regarding with the bleaching powder, preparation of bleaching powder, properties of bleaching powder, and uses of bleaching powder. Now we will learn about washing soda. Washing soda which is we are using in our home. Okay, so this is washing soda. Its formula is Na2CO3 10 times H2, 10 times H2 hydrated. Okay, so you know that uni means 1, bi means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9, and deca means 10. In the chemical name of washing soda, the term used deca, and deca term is used for the 10, number 10. Okay, so it indicates how many numbers of H2 present in the washing soda. So chemical name of this washing soda is sodium carbonate decahydrate. Sodium carbonate decahydrate. Anhydrous Na2CO3 sodium carbonate is commonly known as soda ash. Anhydrous Na2CO3 only. What I am saying? Sodium carbonate only. Only for the sodium carbonate it is called soda ash. Okay, so how this washing soda is going to be prepared, we will see first. Simple reaction is there. Whenever this sodium carbonate is reacting with the 10 molecules of water, at that time it forms Na2CO3 10 times H2. I am again repeating it. Na2CO3 plus 10 times H2O, it gives sodium carbonate 10 times H2. Okay, 10 molecules of H2O is going to be react with sodium carbonate. At that time it forms washing soda. As you seeing this slide of washing soda, in this slides it gives this obtained by heating baking soda. In terms, there are so many methods of preparation, so you just learn only one, any one, as I told now only. Second method, recrystallization of sodium carbonate giving washing soda. That only you just keep in your mind, that is sufficient for you. Okay, so but also for more information we will see the first reaction also. It is obtained by heating baking soda. In turn it's obtained by passing CO2 gas through the sodium chloride solution saturated with ammonia. Okay, same as it is above reaction. Here we are getting sodium hydrogen carbonate. Okay, and this sodium hydrogen carbonate we are saturating gives sodium carbonate. From this solution, from this above reaction, we are getting sodium carbonate only. Okay, and again this sodium carbonate, we are just recrystallization of sodium carbonates. We are doing recrystallization of the sodium carbonates, and we are reacting this the 10 molecules of water, and it giving sodium carbonate decahydrate. Okay, this is the preparation of washing soda. Now we will try to understand about the properties of washing soda. It is readily soluble in the water. It is readily soluble in the water. Okay, it is not rapidly soluble in the water. It is readily soluble in the water slowly. It dissolves in water to form an alkaline solution. It means basic in nature. While we are dissolving washing soda into the water, if we are going to check the nature of this solution, so it will be basic in the nature. Third property, action of heat. What will the action of heat? On heating above 373 Kelvin, if we are heating 373 Kelvin, this washing soda, okay, does not decompose but loses all its water or crystallization to form anhydrous salt. It not decomposes, but what happens? It loses the all its water molecules, means 10 time water is there now, so it will get loss of water crystallization to form anhydrous salts. Anhydrous means without water. Okay, hence monohydrates becomes completely anhydrates, and anhydrous change to white powder called soda ash. First, this decahydrates change to the completely anhydrous, and again if we are going to be heat to this washing soda, it will convert into the soda ash. So this is second property of the washing soda. Now we will try to understand uses of washing soda. We know that, then also we are going to see it. It is used for softening of hard water. It is used for softening of hard water. It is used for washing purposes. In our home, our mothers or a sister or any other ladies are going to be use this washing soda for the washing of clothes. Okay, laundries, cleaning agent for domestic purposes. It is used in the laundries also as a cleaning agent for the domestic purpose. It is used in the manufacturing of sodium compounds. It is used in the manufacturing of sodium compounds like borax. Borax is a compound. Okay, so it is used as a reagent in the laboratory. It is used in the reagent in the laboratory. It is used in the textile industries also. It's used also in the textile industries also, it is going to be used. These are the uses, properties and preparation of washing soda. I hope that you understood about bleaching powder and washing soda. Okay, now we will see about plaster of Paris. Plaster of Paris having formula CaSO4, that is calcium sulfate dot means half H2, and it is known as POP. POP means plaster of Paris. Its chemical name of plaster of Paris is calcium sulfate hemihydrate. Hemihydrate means half H2O. Hemihydrate means half H2O. Now we will see the preparation of this plaster of Paris. Okay, calcium sulfate hemihydrate. This half is used for the water. Okay, half molecule of water it contains, so it is used hemi. Okay, so it is prepared by heating gypsum. It is prepared by heating gypsum at 373 Kelvin in a kiln. So we are just heating to the gypsum. What is the formula of gypsum? That is calcium sulfate 2 times H2. It is the formula of gypsum. It is the formula of gypsum. Okay, so we are just going to heat this gypsum at that time up to 373 Kelvin. Okay, we are going to heat at that time. What happened? The 1.5 molecule of water gets lost, and after that we'll get calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Here it is not 11, it is 1.5 H2O is there. Okay, so we are just heating this gypsum CaSO4 2 times H2O. It is the formula of gypsum. We are just heating it at 373 Kelvin. At that time we are getting CaSO4 half H2O plus 1.5 H2O. Okay, this is the reaction. This is the reaction preparation of plaster of Paris. Now we will try to understand the properties of plaster of Paris. It is white powder. Actually it is white powder. It absorbs water evolution of heat. It absorbs water evolution with the evolution of heat. Okay, it means it gives exothermic reaction. When mixed with water, it forms a paste which sets into a hard mass. Here some fractures, if there are some fractures, we are having some fracture at that time we are using plaster. Okay, when we are mixing water into it, plaster of Paris, okay, calcium sulfate hemihydrate, in that if we are adding water at that time, it's form a paste and which sets after sets it into a hard mass. Okay, it will set as a very hard. This is called setting of POP. This is called what? Setting of POP. Now uses of POP. POP is used for making molds for toys, ceramics, etc. It is used for the molds for the toys or ceramics. It is used for making statues, models. It is also used for the statues or models, decorative materials. It is used in the medical applications known as plaster for setting breaking when broken and fractured bones. Okay, it is used for medical applications also known as plaster settings. Okay, plasters for setting broken and fractured bones at that time which is used. POP is used as fire proofing material. It is used for fire proofing material also. These are the uses of POP. It means plaster of Paris. We seen chemical properties of POP also and uses of POP also. So what we learn today? Today we learn about washing soda, baking soda, bleaching powder, POP. This all salts today we completed with the help of slides. Now just once again see the small AV regarding on the salts. Okay,
Since the sea is considered to be the largest water body on the earth, why is the water so salty that we can't drink it?
The seawater is so salty because it contains large amounts of dissolved salts.
Do we get the salt which we use in our food from the sea?
Yes, of course. Along with common salt, you can get other salts from the sea. Some salts are prepared in laboratories. This lesson is about the occurrence and uses of different salts. At the end of this lesson, you will be able to define salt, list the uses of sodium chloride, explain water of crystallization using an experiment, and list the uses of plaster of Paris. The product of an acid reacting with a base is salt and water. From this, we define salt as a compound formed by the reaction between an acid and a base. This reaction is called a neutralization reaction. For example, when an acid like hydrochloric acid reacts with sodium hydroxide, which is a base, sodium chloride, which is a salt, is formed.
Oh, salt which we use in our food?
Yes, some salts like sodium chloride are edible, and other salts like magnesium chloride, potassium nitrate, zinc carbonate, and copper sulfate are useful to us.
Do these salts have any unique properties?
Salts are mostly solids and are ionic compounds. Every salt has a positively charged cation and negatively charged anion. For example, sodium chloride is made of sodium ions and chloride ions. Do you know how these salts get their name?
No idea.
Salts usually get their name from the acid which takes part in the reaction. Salts formed from any hydroxide and hydrochloric acid are chlorides. For example, potassium hydroxide reacts with hydrochloric acid to form a salt called potassium chloride. Similarly, salts formed from any hydroxide and sulfuric acid are called sulfates. For example, magnesium hydroxide reacts with sulfuric acid to form magnesium sulfate. Accordingly, salts formed from any hydroxide and nitric acid are known as nitrates. Ammonium hydroxide reacts with nitric acid to form the salt ammonium nitrate. Likewise, salts formed from any hydroxide and carbonic acid are carbonates. Sodium hydroxide reacts with carbonic acid to form the salt sodium carbonate. Based on the strength of the reacting acid and the base, salts can be classified into three types. Salts formed from strong acids and strong bases are called neutral salts. They have a pH value of 7. Consider salts such as sodium chloride and potassium sulfate formed from strong acids like hydrochloric acid and sulfuric acid with strong bases like sodium hydroxide and potassium hydroxide. Salts formed from strong acids and weak bases are called acidic salts. They have a pH value less than 7. Consider the formation of salts like ammonium chloride and magnesium nitrate, which are formed from strong acids like hydrochloric acid and nitric acid with weak bases like ammonium hydroxide and magnesium hydroxide. On the other hand, salts formed from weak acids and strong bases are called basic salts with a pH value more than 7. Consider the salts like sodium carbonate and potassium acetate, which are obtained from weak acids like carbonic acid and acetic acid on reaction with strong bases like sodium hydroxide and potassium hydroxide.
Oh, it's too salty.
Seawater contains many dissolved salts like chloride of potassium, magnesium, iodides of potassium, etc. Although the most abundant sea salt is sodium chloride or common salt, sodium chloride is obtained from seawater by the process of evaporation.
Without common salt, food doesn't taste good.
Absolutely. Common salt is an important constituent of food and is referred to as table salt. Common salt enriches the flavor of food. It plays an important role in the functioning of our nervous system, the movement of muscles, and in the production of hydrochloric acid in our stomach. It is also used as preservative in pickles, fish, and meat. Sodium chloride is used in the manufacture of soaps. It is used to melt ice that forms on the roads in cold countries. Sodium chloride is used as raw material for the manufacturing of various other useful compounds like sodium hydroxide, sodium hydrogen carbonate, sodium carbonate, and bleaching powder.
What is sodium hydrogen carbonate?
Sodium hydrogen carbonate is produced when a concentrated solution of sodium chloride reacts with ammonia and carbon dioxide.
Is it useful to us in the same way as sodium chloride?
Yes, it is useful in many ways. One example would be that it is an important ingredient in baking.
Yes, I remember. My mother uses it in the kitchen while she bakes a cake, and she also says that it can even neutralize the acid produced in our stomach.
Baking powder is a mixture of baking soda and a mild edible acid called tartaric acid. Baking soda reacts with the hydrogen ion of tartaric acid and releases carbon dioxide, which bubbles out and helps to raise bread or cake in the process of baking. It is also used as an antacid because, being alkaline, it helps to neutralize the acid of the stomach. Apart from that, it is even used in soda acid fire extinguishers,
which we usually come across those in the multi-storied malls.
That's right. Do you know how glass is made?
No idea.
Sodium carbonate is used to manufacture glass.
Sodium carbonate?
Sodium carbonate is obtained by heating sodium hydrogen carbonate and is called anhydrous sodium carbonate or soda ash. The anhydrous sodium carbonate is dissolved in water and recrystallized to sodium carbonate decahydrate.
How is this sodium carbonate useful to us?
Sodium carbonate is used to manufacture cleansing agents, soap, glass, paper, etc. It is also used for removing the permanent hardness of water. It is used to remove the dissolved salts in the water and make the water clean for drinking. It is even used to manufacture sodium compounds like borax, which is used as a cleansing agent.
I love to play with water, but I feel my skin develops some itching sensation when I play in seawater. I wonder why it doesn't happen when I swim in a pool.
The microscopic organisms or small germs present in seawater irritate the skin, whereas the water in a pool is treated with bleaching agents like bleaching powder that kills insects and germs.
Bleaching powder?
Bleaching powder is chemically called as calcium oxychloride, which is obtained by passing chlorine gas through calcium hydroxide.
Great! What else is bleaching powder used for?
It is used to bleach cotton and linen textiles, and to bleach wood pulp, and even used in the manufacture of paper. Bleaching powder is used to disinfect drinking water and make the drinking water clean and safe. What does your mother do when the kitchen drain is blocked?
She uses a drain cleaner to clean the clog.
Did you know? The drain cleaner contains sodium hydroxide, which cleans the clog formed in the drain. When the pipe is clogged, it is because of a combination of fats and grease. Cleaners that contain sodium hydroxide, either as a solid or already dissolved in water, converts the fats to soap, which dissolve in water. In addition, when sodium hydroxide dissolves in water, a great deal of heat is given off. This heat helps to melt the clog.
How can we obtain sodium hydroxide?
Sodium hydroxide is produced by the electrolysis of aqueous solution of sodium chloride called brine. The electrolysis of brine is called the chlor-alkali process, since the products formed are chlorine and an alkali. In the process of electrolysis of brine, hydrogen is collected at the cathode and chlorine at the anode. The hydrogen formed in this process is used to manufacture fuels, margarine, and ammonia for fertilizers. Chlorine is used for water treatment in swimming pools to manufacture chlorofluorocarbons, PVC, chemical compounds like chloroform, carbon tetrachloride, disinfectants, and pesticides.
What are the other uses of sodium hydroxide?
It is used to manufacture soaps and detergents. Sodium hydroxide is also used to manufacture paper, artificial fibers like rayon, and dyes.
Wow! Why is the sand shining?
Did you observe that it is crystalline? Similar to sand grains, salts also have a crystalline structure. Moreover, some salts have a fixed number of water molecules as an essential part of their crystal. These water molecules which form the part of the crystal are called water of crystallization, and such salts are called hydrated salts. For example, in your laboratory, the blue-colored copper sulfate is copper sulfate pentahydrate. When heated, this salt loses its water molecules and its blue color. Let us perform a simple experiment to verify the presence of water molecules in copper sulfate. Take some powdered copper sulfate in a test tube. Hold the test tube with a pair of tongs and heat it using a Bunsen burner. Observe that the blue-colored copper sulfate turns white. When this powder is moistened with water, the blue color reappears.
Do all salts have water molecules in their crystals?
Not all. Only some salts have water molecules in their crystals. For example, sodium carbonate decahydrate, Na2CO3 10H2O. Ferrous sulfate heptahydrate, FeSO4 7H2O. Zinc sulfate heptahydrate, ZnSO4 7H2O. Magnesium sulfate heptahydrate, or Epsom salt, MgSO4 7H2O. Potash alum is a sulfate of potassium and aluminium with 24 water molecules, K2SO4 Al2 SO43 24H2O.
Poor boy! He's hurt himself, and his arm is in a cast.
Do you know what that cast is made of?
No?
It is made of plaster of Paris. Gypsum, when heated to 100 degrees centigrade, forms plaster of Paris, which is chemically called calcium sulfate hemihydrate, CaSO4 half H2O. This calcium sulfate hemihydrate, CaSO4 half H2O, sets and becomes a hard mass when mixed with water. Some of the uses of plaster of Paris are: for setting fractures, since it hardens when mixed with water and sets in a short time; as a fire and waterproofing material; as a sealing agent in the laboratory for sealing air gaps in apparatus where airtight arrangement is required; for making casts for statues, toys, and decorative articles; for smoothing wall surfaces;